Welcome back, everyone. So in this video, I'm continuing the series on Synth Public Service Commission Lecture in Mathematics exam of 2024. And I'm going to continue from MCQ 21, as you know. So we are done till MCQ 20. And in this video, I'll try to do only 10 questions, then we'll move towards another part, because I don't want to do all the questions at a single time. So MCQ 21 is not about mathematics, it's about English. It says that, okay, we have a sentence and we have to fill in the blank with the preposition given in these four options. So the question is, the package arrived dash the expected delivery date. So like, these are tricky questions, but obviously with practice you can do better on these all the questions. So either it should be on, because in doesn't make sense. Either it is going to be 8, and it can be before as well. So the package arrived before the expected delivery date. So it's like confusing question. So the best option is going to be the package arrived on the day you are expecting. So the package arrived on the expected delivery date. So I'm not good at these, but you can practice by yourself and see which one is going to be the best option. Okay. So MCQ number 22 is about English as well. What type of word is because in the sentence? She went to a store because she needs groceries. So if you see, we have basically two parts of the sentence. She went to a store, and another part is she needed groceries. And this word because is going to connect these two parts of sentence, or it connects basically these two sentences. So a word that connects cannot be a verb. It's not a verb. It's not an adjective. It's not an adverb too. So obviously we know the definition of conjunction is the word that connects to sentences, to words, to phrases. Maybe connects or disconnects, however you take it. So the correct option is C. So let's go to mathematics. The question is, number 23 is x plus 2 is a factor of. So we are given these all the polynomials, and we have to find out where x plus 2 is a factor or not. So we can apply remainder theorem. Okay, if we have x plus 2, we can set it equal to 0. Then we get x is equal to minus 2. So what do? You put x is equal to minus 2 in all of these and see which one of the polynomials gives you 0. If it is 0, it means the remainder is 0. If the remainder is 0, then x plus 2 completely divide that particular polynomial. Hence, we can say that, okay, x plus 2 is a factor of that polynomial which gives you remainder 0. So you can put in this one, let's say you can put minus 2 to the 4 plus 2. So this becomes 16 plus 2, which is 18. So this is not 0. Similarly, like you can check all of these, so just check. So I'm writing here remainder theorem. And if you apply remainder theorem, then everything works out here. And maybe you can check this one and you can check this one. And I think this will give you 0. So this will not give you 0. This will not give you 0. Let's take the last one, minus 2 to the 4. Then this term plus 2 minus 2 to the cube minus 2 and minus 2 at the end. So now we have 16, and this is going to be minus 8 times plus 2 is going to be minus 16, minus into minus, plus 2 minus 2. So this is 16 plus 2 minus 2 cancels out, you get 0. So as I told already, this is going to be the polynomial. And you can also check B and see whether they work or not. Okay, next MCQ is the two non-zero vectors A and B are parallel if, so we know very well that, okay, if you take the cross product of two vectors, and if the cross product is 0, then we know that these vectors are parallel, because the cross product of two vectors is defined to be the length of vector A, the length of vector B, times sine of the angle between these two vectors. Now, if the vectors are parallel, it means the angle is 0. And we know very well sine of 0 is 0. So the angle can be 0 or pi, it depends, because whatever the direction you're talking about, if they are in opposite direction like this, then we can say that, okay, the angle between them is 180, and sine 180 is also 0. So sine 0 is 0, hence the cross product is going to be 0, and all the other options are not relevant. So we are not going for these options. MCQ number 25 is a bit misleading because it says that, okay, find an if the function, okay, given the function find an, it doesn't make any sense, but we can understand this question in this way. If the function is, what do we say, Taylor or Maclaurin series to be, so if the function is this Maclaurin series an x to the n, or whatever you call it, Maclaurin or Taylor series, when n runs from 0 to infinity. So this is the Taylor series of the function. So you have to find out what is this n, but explicitly you don't need to tell what is the value of n. You only need to tell, okay, whether n has finite value, infinite value, 0, or it can't be found. You can see this is a polynomial. So I can write this polynomial function as 0 plus 1 times x plus 0 times x square minus 1 times x cube, 0 times x to the 4, 0 times x to the 5. Why I'm doing so? Because you can see the only term x is this one, and minus x cube. Oh, sorry. This happens sometimes. So minus x cube is this one, and all the other terms are 0. You can see 0, 0, 0, 0, and so on. So you can consider this is going to be the Taylor or Maclaurin series, and you can see A1 is going to be 1, and because this is A1, and this is corresponding to A3, which is -1, and AN is 0, because all other ANs are 0 when n is not equal to 1 and 3. So hence you got some values, okay. A1 is 1, A2 is 0, A3 is -1, A4 is 0, A5 is 0, A6 is 0, and so on. So what should be the correct option? So you can see the correct option is finite value, because these are not infinite values, and these all are not 0 too. So C is not correct because some of them are non-zero as well. And D's can't be found, so we can find these values. So although the question was misleading, like not misleading, but there was like maybe not the whole information given in the question, but you can think of this question in this way. Okay, so here this equation is given to us, and we have to just tell that, okay, this equation represents a circle, a parabola, an ellipse, or a hyperbola. So according to the definition of like if you look at the definition of an ellipse or a hyperbola, so I'm going to tell you. So let's say this is an ellipse. Maybe it looks good or not, I don't know. So there are two fixed points in this ellipse, and if you take any point on the ellipse, and if you find this distance, so this distance and this distance, so the sum of these two distances is always a fixed number if you're talking about the ellipse. So you can see, let's say Z is here, a point in a point in this coordinate plane, in R2 plane. And this shows the distance of z from 3, and this shows the distance of z from -3. So let's say this point is 3 and this point is -3. And this is the sum. The sum of these two distances is always a fixed number. Let's say that fixed number in this case is 5. So technically, it should be an ellipse. Should be an ellipse. But the problem is, if you apply only like simple mathematical tools, or maybe if you apply triangle inequality, you find that, okay, this distance from -3 to 3 is 6, because 3 on one side and 3 on the other side, this is going to be 6. And this distance plus this distance, so sum of these two distances should always be bigger than the third side of the triangle. But the sum of these two distances is 5, and 5 is not bigger than 6. So this thing doesn't make sense to me. So this question is like, I'm looking for something and I'm not getting that thing in this question. So this question should be maybe 3 minus z and 3 plus z. Their difference should be equal to 5. If the difference is 5, then this is going to be a hyperbola. Okay, so if maybe this is not plus and this is minus, and there's a mistake in this question. If this is plus, this number should be bigger than 6. Otherwise, this whole thing doesn't make sense. Like this number should be maybe 7 or something. So this can be, if this is plus sign, this is an ellipse, but this number should be bigger. And I'm sorry for this again. And if there is minus sign here, then I think it makes sense, and then it's going to be a hyperbola. So this is the whole understanding of this question. So next question is, what will be the condition for L'Hopital's rule to work? And we know very well the condition is going to be like, okay, the function which is given to you should be of the sum of the indeterminate forms, and which is this option C. Like if you have a function which is sine x divided by x, can you apply limit x tends to 0? You know some answer from some formulas, but can you apply L'Hopital's rule? The answer is yes, because if you put directly 0 here, sine 0 is 0, and if you put 0 here, you get 0, and 0 divided by 0 is one of the indeterminate forms. So the so the so the solution is like, you can apply L'Hopital's rule here. That's it. So it should be this one, option C. And next one is, one of the foci of the hyperbola which is given to us is this point. We know very well this focus is always this 0 and plus minus c. So one focus is 0c, another focus is 0 minus c. So what we can think of, maybe this is 0c, so this is 0 is square root of 2, the value of c, and this is 0 minus square root of c. So if these are two foci of the hyperbola, then the hyperbola should look like this. Sorry for my drawing. So this is going to be the vertex, and the question is, okay, what should be this A? What should be this A? So I think A is this vertex, and we have to find out what this value is. So from some formulas of hyperbola, we know very well that if you take this C and square it this value, and it should be equal to A square plus 1. So if C is given to you, you can find A easily. So C is square root of 2 squared equals 1 plus A squared. So this is 2, because a square and a square root gets cancelled. And maybe this one comes from the value of B, which you can find here. Yeah. I think this is divided by 1, so the value of B is 1. So you can take 1 on other side. So this becomes a square is equal to 2 minus 1. So a square is 1. So a is equal to, if you take the square root plus minus 1. So you can see the correct option is going to be 1. Yeah. So this is all about like the FSC mathematics that you guys are doing. So you can find these all the things in your FSC books. Question 29 is, we have a polynomial over the real number has these complex roots. So one of the roots is 2 plus I, another root is 1 minus I. Then f of x could be, so the question is, what should be the degree of the polynomial? Because we know that if there is one of the roots 2 plus I, there should be another root 2 minus I as well. So these roots always appear in these conjugate forms. You do not have like a real polynomial with real coefficients, and the roots are going to be only one complex, not the other. So these always appear in pairs. And if there is 1 minus I, there should be another 1 plus I as well. So there are basically 4 roots you can see. So the degree of the polynomial should be 4. So it should be either this one or this one or this one, or maybe none of these. We don't know. So what you can do is you can find the polynomial explicitly by doing this calculation. So x minus, you write your root, whatever it is, alpha 1, x minus alpha 2, x minus alpha 3, x minus alpha 4. So you do this calculation and you check what happens. That's your answer. So x minus, you can take your alpha 1 to be 1 minus I, and this is your alpha 2. So x minus 1 plus I, and x minus 1 minus I. And this is like, you can see this thing is alpha 3 and this thing is alpha 4. Then x minus 2 minus I, and x minus 2 and plus I. Now what you need to do, you need to just expand and multiply these brackets and see what happens. To me, I think this is like near to this option C, but I think there is some sort of discrepancy here, which you can see. I think this is not going to be 7x squared or something else, but you can check this. And it's going to be none of these, because none of the options is going to be the answer that we are getting from this calculation. And you can do this calculation by yourself, I know. Okay, maybe last question for today. Which of the following circle has the largest number of points of intersection with this parabola? So the question is like, how does this parabola look? So this, if you want to write this equation, this is going to be y is equal to x squared minus 4. So we know very well y is equal to x squared looks like this. So there, if there is minus 4, you are going to take this down 4 units. So this will be something like this. So if you want to explicitly draw this parabola, I'm doing that thing here. So you can find what are going to be the intersection points, maybe -1, -2, -3, -4. This -4 is one of the intersection points. If you put x is equal to 0, the value of y is going to be -4. And if you put y is equal to 0, then you will get x squared minus 4 is equal to 0. So x squared is equal to 4. So x is plus minus 2. So these are two other intersection points, like the x-intercepts. So this is 1, 2, 1, 2. So this is 2 and this is -2. So these are two other intersection points. If you want to draw the parabola, then it looks like this. Maybe something like this. So now you have to draw these circles. So now you can see the equation of the circle with the center to be the origin is always this thing, x squared plus y squared is equal to radius squared. So radius squared is 2. So radius is going to be square root of 2, which is like near to 1.4. So this is a circle with radius 1.4 and center is origin. So center is origin, radius is 1.4. So this is, 1 and this is something 1.4. So I have to draw a circle here. So almost this one. So you can see this is your parabola, and this is a circle, and how many points of intersection? You can see there is no point of intersection, so I can write here 0. So there is like 0 points of intersection. For the second circle, the radius is 3. So you can see like now I'm taking this 3, maybe 3 lies here, and I'm not sure, something here as well. 3 lies here, and then I can draw a circle here. I'm sorry. And like there's some issue, but you can see this, if this point is 3, then you can count the points of intersection. One point is this one, another point is this one, another point is this one, another point is this one, because this is the parabola. So you can see there are 4 points of intersection. So 4. Similarly, for this one, you can find how many points of intersection. So radius from this one is going to be 4. So 4 is here, 4 is here, and this is obviously, -4. So there is a circle that goes like this. So if you count for this one, this is one point of intersection, this is another point of intersection, and this is the third point, which is not exactly intersection, but it's like, okay, it's just touching it. So there are 3 points. So if you look at this circle, this is going to be even bigger circle with radius 5. And you can see like from below, it's not touching this parabola because the parabola goes like this. But from the top, this only circle like intersects at 2 points. So this is 2 points. So obviously you can see this is this one, which intersects at exactly 3 points. So, sorry, 4 points. So this is going to be the correct option for this. And see you in the next video.